Hello, folks, and welcome to another More Than a Refresh, the T3D Sessions. Our guest today is Silona Bonewald. Silona, what are we talking about today?
10 things you didn't know about blockchain.
Hit me.
Well, so when I thought about this, I was thinking about kind of doing a systemic historical approach. And so I feel like a lot of times people think that things suddenly exploded out of the ether and it was all out of this one guy's mind and yada yada. And so I wanted to kind of dispel that myth a bit. And so one of the first things that I wanted to sit there and say is, first of all, blockchain is not crypto. And hopefully the majority of your audience know this, but dear Lord, if it's not something I deal with on a regular basis. So
Oh,
I kind of
sure.
wanted to first, bring that out there. Blockchain is not crypto. Crypto uses blockchain. But blockchain has actually, and this is the second thing that you might not have known, was actually created in 1990 by Stuart Haber and Scott Stonata, where they announced it at Crypto 90. Well, and of course, the funny thing about that is when they say crypto in 1990, they meant cryptography. They didn't mean
Right,
cryptocurrency. And we've been
right.
watching that change, and like old fuddy-duddies like me occasionally go, ah, because I have to always disambiguate whenever I'm saying the word crypto, either cryptocurrencies or cryptography. Um, the next thing is the number 3 one is smart contracts were actually invented in 1994 by Nick Szabo, where he was doing something in regards to, he was both had a CS degree and a law degree. And so he first started doing some of the very first smart contracts. Secondly,
Hold on a
mhm.
second. Talk to me about this smart contract thing. What is this exactly?
So smart contracts in blockchain is when you can go in and you can enforce different rules so that when they interact under different rules. So that's what the smart contracts are. So when you're going in there, you're adding a form of automated governance. And in fact, Nick has a really good article warning about the dangers of automated governance, because when you sit there and you make a computer do something that is supposed to be a legal decision, they cannot be held accountable for it. And so you have to be very
Right.
careful in regards to how you do that, as to who holds the accountability into their palms, because it's not going to be the computer. Because when people get sued, people get sued.
Right.
So yeah, so he did some of the first automated computer smart contracts. So
Okay.
that also existed. Back in 1995, the New York, and this was the oldest large instantiation that I could find of blockchain itself. And this was done by those original inventors in 1990. They did a blockchain with the New York Times where once a week they published their hash under the classifieds. So that's how they did their immutability, is it had over, at the time, I don't know how big the distribution was of the New York Times in paper, but, it was in the hundreds of thousands, if not, the millions. And that's how they actually went through and did one of the very first blockchains that was a mashup of both digital and physical. And that's kind of how they overcame the citability question, is by going through and doing that. And then, of course, I have to pitch my little bit right in here. In 2004, I did one called the Transparent Federal Budget Project, where I took Mercurial, which at the time was a versioning system similar to Git,
Mm-hmm.
and added Merkle trees to it. Merkle trees were invented in 1979. And in fact, one of the main reasons blockchain came into being, and this is from conversations I've actually had with Stuart, is that he had the same problem with databases that I had, in that, viewing the admin as being a singular point of failure and not being
Mm-hmm.
able to trust digital data from being altered. And so that's one reason he went through and created a lot of that. And that was the same thing behind mine, is that I was sitting there going, I've got to sit here and publish the federal budget. And I had the ACLU, the Consumers Union, the Cato Institute, and the Heritage Foundation all in the same room, different times.
I was like,
And we were all,
that sounds like a tense meeting.
well, you know me, Josh. I made a party out of it and made it fun. And of course, one thing that is always important to this Southern girl is good food. We had really good food.
Okay.
So that made everything a little easier. but we didn't trust each other, right? So how did we
Right.
enforce the trust? And it was through the Merkle trees and having the hashing where anyone could go through and do it. So it was like archive.house.gov/session/bill number/date timestamp pound title section subsection chapter subchapter paragraph clause. And so you could point to any item in the budget, any line item, and that way they could also add their own documentation to it and have all of that be a citable reference. And a lot of that was because of the fact that we were missing this immutability, because in print, we have this weird immutability that happens when we print so many different copies of a book. You can't go through changing all of those books, right? It's really difficult to do. So that's how we ended up creating immutability, but we hadn't thought about that in regards to the digital one, or a lot of people hadn't. And so that was like, how do you introduce that in? And so that was like the early reasons for blockchain. And then number 6, open source's role. I don't know if, and once again, this is historical. And in fact, the first version of Bitcoin was uploaded to SourceForge. But SourceForge started having problems with injection attacks. And where things were getting injected into the code bases and all these different stuff was happening. And so they were trying to do where at the time you had to actually check the digital hash to sit there and see if it was the right one when you downloaded off of the internet, and make sure that you were actually getting the piece of software that you thought you were doing.
The checksum.
But the problem with SourceForge is they could inject it before that happened. And so that's why GitHub came into being. And GitHub was very similar with the Mercurial and the Merkle trees, where they went through and they did a SHA hashing between every single instantiation. So every time you had a new version or a new piece of it, they would go back and check through it. Of course, I'd like to point out that it's all still SHA-1, and we all know how hackable that is. So maybe we need to be rethinking that. And then for number 7, where decentralization came from. Decentralization, came from, there were some very early instantiations of other types of that in regards to grid, because, I worked at grid.org, so I'm a little biased in regards to that, in regards to when that got started. And I got to work for the fathers of grid computing, where you could have all the distributed computing and you could do things like SETI at home and help find, aliens, or protein folding at home, and, help cure cancer and things of that nature. But also what came into being out of that was peer-to-peer. And that's where you truly got, a lot of huge contributions that end up becoming part of cryptocurrency, as well as blockchain, because you got in things like, you learned in Napster that centralization was bad.
Right.
You learned with Nutella that they did a lot of different stuff in regards to scaling, because one of the hard things a lot of times with decentralization is scale if you don't know how to do it correctly. They helped a lot with search and discovery. BitTorrent did a lot in regards to balancing things out with tit for tat, so that nobody could do a large download style attack. And then Core DHT did a lot in regards to routing and trust. And then, of course, BitTorrent also tit for tat helped with the rewards portions. So you have all these big things that came into play to help get us where we are today in regards to blockchain and having all these different things. But, the other thing about blockchains is not everything is decentralized. There are permissioned blockchains. In fact, I used to be the VP at Hyperledger, and those are permissioned blockchains. And so that's one of the things that I wanted to bring up is number 8 would be the fact that Estonia has completely tokenized their power grid, and has seen huge savings from doing that. Where it's been savings on the government side in regards to how much work they have to do and how much redundant work that they have to do. And then they found huge savings that they were able to pass down to the customers as well. And for all of that, they were allowed to do peer-to-peer sharing of solar power. And one of the things that's really interesting about that is most people don't realize the big problem with solar and wind is transporting it. And saving it and things of that nature. And so the more that you can distribute that out and distribute it locally, the greater power savings that you're going to get. And so they estimate that, they got anywhere from 18 to 24% on that. And then another really cool project is British Columbia has been using Hyperledger Indy and a bunch of other products like Sovereign and such to redo a bunch of their governmental programs, both climate sustainability, in legal. They're doing things in regards to lawyers being able to verify themselves and then get legal documents securely. And then they also have OrgBook, which is where every legal entity in British Columbia is registered there. And so they can do all the permitting and things like that. And so they estimate that they were able to do 78% reusable code, and they saved $34 million.
Wow. All right, what's number 9?
So number 9 is that most people don't realize that proof of stake, not proof of work, but proof of stake uses less money than traditional banking and uses less energy than traditional banking. Because everyone complains so often about a lot of these different, yes, because if you use proof of stake, you don't consume the amount of energy, especially if you consider all of the other different things that you have to put in place to replicate what proof of stake does, and doing blockchains for financial transactions and all the different ways that it runs. Because we're not just talking about the fact that they hold all these transactions and do the reconciliations at midnight, right? Because most people don't realize that it actually takes at least 3 days to do a banking money transaction. PayPal, all those other guys, they're gambling.
Yes.
Most people don't realize that, but they're gambling. Anything where there's a direct money transfer that happens in less than 3 days is gambling. It can take up to 14 days in the United States if it's over $10,000 or over 3,000 euros in Europe. Because then it goes through the terrorist double checking. So all of those different things. But if you didn't have to have the all of the different banks and the ATMs, and you actually were able to distribute out the data centers better, and you could do all those other different things, proof of stake pretty obviously becomes an energy win.
All right, and
most people don't realize that.
What's our number 10?
Our number 10 would be the 51% myth.
Oh, 51% myth. What is this?
Yes. Well, everyone sits there and believes that, Bitcoin could be taken over, any of the cryptocurrencies could be taken over with 51%. There are many different ways to prevent that, technologically speaking. And it also makes no sense if people have invested lots of money that they would ever actually go in there and do that. The only ones that you would ever have to worry about losing that amount of money would be a nation state. So a lot of times people like to throw around this thing about, in regards to decentralization, all these different things that could happen. And for the most part, with current technologies, it's pretty much a myth.
Okay. Well, with that, this has been another T3D session. Silona, thank you so much for that list. We should do something a little longer next time because there's a lot of interesting history there that we could probably get into.
Oh, totally. And not only that, but I think that blockchain could solve our AI issues.
That's a different topic.